So hello everyone, welcome to this new video. So in the previous videos we had solved two important problems related to the design of linear phase FIR filters using windows, right? And we have solved two important problems and we have seen the relationship between the desired frequency response and the actual frequency response along with the filter coefficients x of n using FIR low pass filters. Okay. So again in this session we are going to solve problems related to low pass filter only in order to make you more thorough about these kind of problems. Two problems are there in this session. We are going to solve it in a very quick manner. This time we are going to use different windows. In the first two problems in the last session we have used rectangular window, right? So now let us see one problem using Hanning window. Okay, Hanning Hanning window. The question here goes like this. Again, those who have not watched those previous videos, please do watch those previous videos and do support us and do like, share, subscribe. Okay. So now let's get to this question now. The third question of this series, that is design the FIR low pass filter using Hanning window with the cutoff frequency omega c is equal to pi by 4 radians per second and the length of the filter is equal to 5. Okay, they have again used this to low pass filter. First write the desired frequency response hd of omega, that is equal to e power minus j alpha omega, right? So first find the value of alpha. The formula for alpha I have told you, it is n minus 1 by 2, right? So alpha is equal to, the value of n here is 5. So 5 minus 1 by 2, that is 5 minus 1 is 4 by 2. 4 ones are 4, 2 ones are 2 twos are. So alpha is equal to 2. So it would be here 2 omega for, again they have told low pass filter, so the range for omega c is equal to minus pi by 4 to pi by 4, right? For others it is 0. So hd of omega we have written. The next step is to find the value of hd of n. The formula for hd of n is 1 by 2 pi and the limits are from minus pi by 4 to pi by 4 in this problem. hd of omega into e power j omega n d omega. Okay, that is 1 by 2 pi minus pi by 4 to pi by 4. hd of omega in this case is e power minus j 2 omega into e power j omega n d omega. So 1 by 2 pi minus pi by 4 to pi by 4. I have told you, right, e power j omega you can take common, n minus, here we have 2 now. In the previous problems we had 3, so n minus 2 d omega. Now take the integration 1 by 2 pi. Write this term as it is first, e power j omega n minus 2, and the coefficient of theta here, that is j into n minus 2, along with the limits from minus pi by 4 to pi by 4. So substitute that limits now. E power j omega is pi by 4 in n minus 2 minus e power minus j pi by 4, since we have minus pi by 4 as the lower limit, n minus 2 divided by j n minus 2. Okay, so this much we have written. Next is the final answer of hd of n, that is equal to sine theta, right? In place of theta what we have here, pi by 4 n minus 2 divided by 2j is done. Next remaining terms are pi into n minus 2. So here we got one value of hd of n. This value is for n not equal to 2. Okay, in this case now the value of alpha is 2, right? Yeah. Now similarly we should be finding the value of hd of n for n equal to 2. That is hd of n is equal to 1 by 2 pi. Limits are from minus pi by 4 to pi by 4. This part you should be considering now. Okay, that is e power j omega n minus 2 d omega. Substitute the value of n as 2, so 1 by 2 pi minus pi by 4 to pi by 4. If you substitute the value of n as 2, 2 minus 2 is 0, e power 0 is 1, so you would be left with only d omega. So 1 by 2 pi integrated, d omega integration is omega minus pi by 4 to pi by 4. We would be left with 1 by 2 pi, upper limit minus lower limit, pi by 4. Minus of minus pi by 4 is plus pi by 4. So it is 1 by 2 pi. Denominators are same, so add the numerators. Pi plus pi is 2 pi by 4. So 2 pi gets cancelled. Our value of hd of n is equal to 1 by 4. Okay. So this is the value of h. These two are the values of ht of n in this case. One is for n not equal to 2 and one is for n equal to 2. So now group those values. That is hd of n is equal to sine of pi by 4 n minus 2 for n not equal to 2, and it is 1 by 4 for n equal to 2. So this is the value of, these are the values of hd of n. Now we should be writing the window, right? That is for n equal to 7. Again draw one sufficient big window so that we would be fitting all the 7 values. So first column is all the values of n from 0, 1, 2, 3, 4, 5, 6 up to 6. Next is for hd of n. hd of n, you should be substituting this equation in the calculator here. Next is omega n, but here now you should be using the Hanning window, right? We have one slight change here that I am going to tell you now. Finally, the value of h of n, that is hd of n into omega n. Okay, that you should be multiplying here. Here in this case it is not 1 because for Hanning window we have different definition, right? Yeah. But before that, let us find the values of hd of n now. Okay, first let us write the value of n equal to 2. Oh, so sorry, I have made one mistake. This is for n equal to 5, right? Not 7. Here the filter coefficient length is 5, so we won't be having last two values, only from 0 up to 4. Okay, because it is 0 to n minus 1, that is 0 to 5 minus 1, it is 4. So 0 to 4, since in the question they have given n equal to 5. Okay, so sorry for that. Yeah, so now let's find the values of hd of n. Put this equation in the calculator, divided by pi n minus 2. Okay, put that equation in the calculator. Don't forget to put the calculator in radian mode, it is very important. So sine of pi by 4 into n minus 2. To put one more bracket and write separately pi by 4, close the bracket, again open the bracket and write a minus 2. In place of n, substitute as a. These two are multiplied. Now close the bracket for this outer bracket, divided by pi into a minus 2. Okay, press the calc button. Find the first, put the value of n equal to 2 here, that is 1 by 4, 0.25. Okay, now check the values of 0 and 1, because if you check for 0 and 1 it's enough. The 3 and 4 are the mirror images of the values. Okay, yeah. For n equal to 0 it is 0.159. For 1 it is 0.225. So here it will be 0.225 and this is 0.159. If you want, you can check. For n equal to 3, 0.225, n equal to 4, 0.159. Okay, so these are the values we got for hd of n. Now the next task is to find the value of omega n, right? Using Hanning window, again they have told us Hanning window, and the formula for Hanning window is Hanning, right? So this is the window here, Hanning window. The formula is, for the value of omega n is 0.5 minus 0.5 cos 2 pi n divided by n minus 1 for all the values of n equal to 0 to n minus 1. In this case it is 0 to 4. So this whole equation here, put it in the calculator, and whatever answer we get, you write it here. Okay, the same thing. In rectangular windows, what we had all the values as 1. So the Hanning window equation, write it here. Okay, see this here, 0.5 minus 0.5 into cos 2 pi n. In place of n you write a, divided by n minus 1 in the numerator, that is n minus 1. The value of n is 5 and 5 minus 1 is 4. So write directly as 4, close the bracket, and this is the equation here. Press the calc button and check for all the values. That is, first is for 0, it is 0 only. So here if you multiply it with 0, you will be getting 0 as the answer. Okay. Next, check for n equal to 1. It is 1 by 2, or you can write it as 0.5. Next, check for n equal to 2. It is 1. So again we got the first three values, and these two would be the mirror images. That is, this would be 0.5 and this would be 0. You can check it. For n equal to 3 it is 1 by 2, 0.5. For n equal to 4 it is 0 again. Okay, yeah, so our this final value also would be 0. Now finally multiply these two, 0.225 into 0.5, that is equal to 0.1125, and this is 0.25 only into 1, and this is again 0.1125. So these are the 5 filter coefficients which you have got using Hanning window. Okay, so hope this problem is clear. Please note it down. So similar problem is there, one more, let us solve that. Okay, so this is the next question here. The question is, find the filter coefficients of FIR low pass filter with the value of length of the filter is 7, n equal to 7, and omega c is 3 pi by 4 radian per second. Again this time they have used Hamming window. Okay, this is not Hanning, this is Hamming, Hamming, Hamming window. Okay, now the window is changed. Now formula also would be changed at the table at the end. So first thing is first, that is write the standard value of HD of omega, that is e power minus j alpha. In place of alpha it is n minus 1 by 2. So the value of n is 7. 7 minus 1 by 2, that is 6 by 2. 2 ones are 2 threes are, so alpha is equal to 3. So it would be 3 omega. Again they have told low pass filter, so the limits would be from minus 3 pi by 4 up to 3 pi by 4, right? Rest is 0. Now find the value of HD of n, that is 1 by 2 pi. Limits are from minus 3 pi by 4 up to 3 pi by 4. This term here, e power minus j 3 omega into e power j omega n d omega. So that is equal to 1 by 2 pi. Limits minus 3 pi by 4 up to 3 pi by 4. So group the terms, e power j omega n minus 3, right? Then take the integral e power j omega n minus 3 as it is, divided by the coefficient of omega, that is j n minus 3, with the limits minus 3 pi by 4 to 3 pi by 4. So substitute the limits now. So e power j 3 pi by 4 n minus 3 minus the lower limit e power minus j 3 pi by 4, since we have minus 3 pi by 4, so divided by j n minus 3. So this would be, our final answer would be equal to, in place of theta what we have, 3 pi by 4 n minus 3. So sine of 3 pi by 4 n minus 3 divided by pi n minus 3, right? So this is the value of HD of n for n not equal to 3, right? Similarly solve for n equal to 3, that is HD of n 1 by 2 pi, limits from minus 3 pi by 4 up to 3 pi by 4 e power j omega n minus 3, right? D omega. Substitute the value of n as 3, so this would be 3 minus 3 is 0 and e power 0 is 1. So 1 by 2 pi, we are left with minus 3 pi by 4 up to 3 pi by 4 d omega. So integration of d omega is omega itself. Limits are from minus 3 pi by 4 up to 3 pi by 4. Substitute the limit. In place of omega, upper limit 3 pi by 4 minus the lower limit, minus of minus 3 pi by 4, that is plus 3 pi by 4. So denominators are same, add the numerators, so you will be left with 1 by 2 pi into 3 pi plus 3 pi is 6 pi by 4. So 2 pi 1s are, 2 pi 3s are, so our answer of HD of n is equal to 3 by 4, right, or 0.75. So these are the two values of HD of n. Okay, those two values, let us write it now. Okay, HD of n, the values we got is sine of 3 pi by 4 n minus 3 divided by pi n minus 3. This is for n not equal to 3, and for n equal to 3 we got 3 by 4. Okay, now write the window for n equal to 7 again. make 4 columns, all the values of n from 0 to n minus 1, that is 6. Next is hd of n, that is you should be putting this equation in the calculator. Then we have omega n, that is here in this case we are using Hamming window, so the equation would be changing compared to last problem. So finally it is h of n, omega n dot hd of n. Okay, yeah, so first let's find all the values of hd of n. Put this equation in the calculator, that is sine of 3 pi by 4 into a minus 3 whole divided by pi into a minus 3. Press the calc button, check the values of 0, 1, 2. The value of 3 here is 3 by 4, that is 0.75. Check the values of 0, 1, 2 and rest 4, 5, 6 are the mirror images. Okay, so the value of 0 is 0.075. For 1 it is minus 0.159. See, one we got the negative value here. In these kind of Windows problem, the negative values are also common. Next is for 2, 0.225. For 4 it is again 0.225. For 5 it is minus 0.159. And for 6 it is 0.075. Check it if you want. For 4, 0.225. For 5, minus 0.159. For 6, 0.075. Okay, so this part is done. Now omega n, that is Hamming window equation. So what is the equation of Hamming window? So this is the equation of Hamming window here, that is 0.54 minus 0.46 cos 2 pi n divided by n minus 1. This you should be substituting in the calculator. Okay, substitute that and find the values of omega n for all the 7 values. That is 0.54 minus 0.46 cos 2 pi, in place of n write a, divided by n minus 1, that is 7 minus 1 is 6. Press calc button. First value is for 0, it is 0.08. Next is for 1, 0.31. For 2, 0.77. For 3 it is 1. Now all 3 values are mirror images, that is this is 0.77, this is 0.31, this is 0.08. Okay, check it if you want. This is for 4, 0.77. For 5, 0.31. For 6, 0.08. Okay, finally multiply 0.075 into 0.08, that is 6 into 10 power minus 3, so 0.006. Next is 0.159 into 0.31 minus 0.049. Next is 0.225 into 0.77, 0.173. So next is 0.75. Again these 3 values are mirror images, 0.173 minus 0.049, 0.006. So these are the filter coefficients which you have found. They have told us to determine the filter coefficients, right? So we have found it. So yeah, that's all for this session, guys. We have solved 2 important problems. Please go through the problems. Do support us, guys. Like, share, subscribe to our channel. Do watch these videos. These problems are very important. Okay, so that's all. Thank you.